a quick introduction about myself. There is already an introduction done. In short, 15 years of experience ranging from administration to development to security. The agenda that I have for today is to deal with the InfoSec landscape to begin with, but then talk about why there is a need for people to be cross-skilled, and then go about talking how can you proceed forward with cross-skilling yourself and having more capabilities than where you are right now. So this is a very broad view of the information security landscape. As you can see, there are too many branches, too many subcategories within the information security landscape. The problem that comes is when you have these many landscape options, you end up specializing in one specific area. You're either a defender, you're either a attacker, you're either a developer, you're either a ops person, or you are a security person. You never try to pay attention to what other people are doing. And because of that, the major problem that comes is, one, you're not aware of what the other person is doing. So when you give a recommendation, which is a very common thing, so a security professional giving a recommendation to developer, all you have to do is just patch. What's the big deal about it? A developer asking a security professional, all you have to do is pen test. How much more time do you need? 3 hours is more than enough time for it. Or a developer talking to an ops person, it works on my machine, why is it not working at your end? Most of these problems stem from the fact that we are not aware of what is the work culture, what is the work profile of the other person, how they are able to handle the work. The other problem that comes with this is the demographic and ground realities. When a developer says, hey, give me a 16 GB RAM machine with 200 GB of hard disk space, the ops person is looking at their AWS graphs or their ESX system and trying to decide which server I can leverage this much data from. Or if I'm using AWS cloud, it seems okay to say that yes, with AWS you can scale instantly. Anyone who has been into the ops world would realize it's not as simple as it looks. Every region has a CPU threshold. The moment you hit it, you cannot provision more CPUs in that area, and you have to either change region or basically get into a point where you apply for a region quota extension. Again, takes a few hours to do, maybe a day, maybe 2 days, and then you get the extension. So it sounds easier to say that yes, everything is automated, it's cloud ops, and with a click of a button, everything works. But there are still humans, there are still processes, and those do cause problems in the system. Now, how do you bridge this gap? One of the easiest way to bridge this gap, especially now, is to do self-learning. Someone who's doing a lot of ops work can try to do a bit of security, a bit of development, feel how the other person is moving through their journey. You don't need to be a full-fledged developer, but if you have some skill set into developing code and deploying the code, if you've gone through the whole process of taking nothing, building a software, deploying a software, performing the tests, doing the validation where someone is trying to attack you, and then how do you try and secure yourself? Once you have the whole journey, that's when you start realizing what are the problems other people are facing. Now, this empathy angle is a very needed angle. It's a necessary and a needed angle which is missing most of the time. Anyone who is into product security or who has dealt with cross-functional interactions would agree that people don't have empathy about what the other person is doing. And that's kind of what I'm trying to do here. Do self-learning, understand what the other people are doing, and in the process, you would enjoy. I'll give examples of how I've done a lot of things. You will end up enjoying the whole process. Now, Homelabs. When I'm talking about Homelabs, why now? Homelab as a concept is there from a very long time. However, what has changed is, now you have capability to buy hardware for say 5,000 rupees. Maybe a fresh hardware, maybe a second-hand hardware, the cost has come down drastically. Also, cloud has provided a lot of free resources. Lots of free resources are available over cloud. If you're not aware, if you have an Oracle Cloud account, they're offering one VM, an ARM version of one VM, free for lifetime. So whatever they consider as lifetime, you have access to a VM throughout that lifespan. Similarly, automation has come up. Earlier, everything required a lot of manual work. You have to configure systems. You have to provision something and then wait for the shell to come up. Once the shell is there, install packages. Once the packages are installed, do the configuration, copy config from somewhere, edit variables, get the whole servers up and running, and then the process moves on. Compare it with what you have now, ready-made template, Ansible or Terraform scripts. Just change a few variables at the top, run it against a target, and it does all the job automatically. So the friction to get started is reduced, the capabilities are more, and the facilities are available. So why not we go for a home lab? First-hand experience, it builds the confidence, it provides the background. Saying things like patch is easy, doing the patch is when you realize, yeah, when people say that I can't immediately upgrade, this is why they are saying, because as soon as I did that upgrade, my entire server went down and my website is down. Now, in Homelabs, you can host your own servers. It could be something like you're hosting your own website, off-the-shelf products, say WordPress, say Joomla, whatever you want to host. You can have containerized applications if you need containerized applications. You can have HTTP server, DNS server, firewalls. We talk about these technologies in commercial space, in corporate world a lot. That, hey, a rule on firewall or change the DNS settings. But when you actually do it, that's when you realize what are the problems. When you say, hey, to the ops person, hey, this is the DNS entry, I want it changed, I am applying for a certain application, I need this DNS entry to start resolving in next 30 minutes. Depending on your DNS service provider, a DNS resolution might be a 5-second job, might be a 2 days job. It totally depends on that particular service provider, and you don't get that idea till you have actually explored options, till you have actually done it and faced the problems. And now, on the other side, you can also use the Homelabs to solve your own problems. I think everyone here has faced the problem of advertisements on their network devices, advertisements on your, Kindle Fire Sticks, or advertisements on your devices which you cannot change a lot of settings for. Setting up a Pi-hole kind of a device allows you to protect against them. Having a NAS for yourself or having a local cloud for yourself allows you to keep a backup of data. You don't actually need Google Cloud as a backup station for everything. You can have alternate solutions. You can isolate your network so that any IoT device that you connect, you don't actually have to worry about them because they are connected via a separate router. You can have VPN network where you can connect to different devices, you can dial back to home, or just have a network of VPN devices so that you can access your devices from across the globe. Password managers, another big problem with LastPass being hacked and a bunch of other hacks coming in. People are thinking about, hey, can I own that data? So if you have a local lab setup, if you have your own setup, you can own the password manager on your end also. Now, how do you do that? And what are the problems that you're going to face? Do you need your own hardware? Can you do everything on cloud? Do you need upskilling? How much of upskilling would be required? And what are the maintenance challenges that you will face? So when it comes to hardware, for some scenarios, it is good to have a hardware. Let's say for Pi-hole. Pi-hole is a software which allows you to do DNS-based advertisement or basically blocking activity. You can have advertisement blockage or n number of domains you can block via Pi-hole. By the name, it sounds like it requires Raspberry Pi, but that's not the case. It's a software that requires a hardware to run. Ideally, it is suggested that the hardware is a portable hardware or a small hardware which remains at a fixed location. But if you want, you can have a Raspberry Pi running on your own laptop also. Pi-hole running on your own laptop also. It'll provide you the blocking capabilities. For running a NAS, obviously you need the hardware physically at your location. But let's say you want to run a website. You don't need to have the hardware at your end. You can have the website hosted on a cloud server. And that would still count as your own lab because you are the one maintaining it and you are the one managing it. If you look at the free for dev URL, you'll find large number of resources which are available free of cost for developers, for people who just want to experiment with systems. From Oracle to IBM to say Amazon to Azure, everyone offers free services. What are those services? What are the options available? That's all is listed on that particular URL. Now, you would definitely need upskilling, and that's the whole point of Homelabs. You need to understand how the other system is working. The good part is now you have you're basically spoiled of choices now. You have enough resources online, you just have to search for it. You want to set up an Nginx server or you want to set up a web server, search for it. You get a detailed documentation, follow the guide. You can get a Terraform script, you can get an Ansible script or a shell script. You just follow the guide, follow it through, you get the setup done. Now the maintenance challenge is where the fun starts. And this is, anyone who has been into the ops domain would be like, yeah, this is my domain. I've done this many times. Software upgrades, hardware errors, and the ownership of business continuity planning or effectively continuity planning and disaster recovery for yourself. Now, when it comes to software upgrade, the only problem that is there in the corporate world is the only thing you need to have right. Have a proper inventory. The exact same thing that corporate world never achieved so far, maintaining a good inventory. But when you have a home lab, you have a smaller environment, you can start with maintaining your own inventory. It could be an Excel sheet based inventory. It could be a software that you want to use. It could be just an entry kept in some text field. But an entry where you know what are the hardwares that you're using, what are the software that are in use, so that you can look back and figure out what are the updates. Ideally, if you're using open source softwares, if you're having softwares which promote or provide RSS feed kind of a system or an email feed kind of a system, you can subscribe to those feeds. Those feeds would help you get a notification as and when the update comes out. For example, I use an ASUS router. The ASUS router officially updates, they only come directly inside the ASUS environment. I don't get a direct notification, but I use a custom firmware called ASUS Merlin. For Merlin, there is an RSS feed available. So I have it subscribed on my email. As soon as a new update comes, I get an email that yes, there is an update. And that gives me a trigger to go and perform the update. And yes, perform periodic updates. Knowing that the update is available is half the story. The other half is actually going ahead and doing the update. Now, hardware issues, you would find these issues. You don't realize hardware issues exist in the modern cloud world because all you are doing is accessing a server. You only get to realize a hardware issue existed and caused a problem when AWS sends you a message saying, hey, you know what, we lost your VM. Why? Because some hardware failure happened and we were not able to recover. Most of the time they're able to recover, but sometimes they fail and they give you that message. When you're dealing with the home lab, that is going to be something you have to be mindful about. It's not a very common occurrence. For example, my last NAS I purchased in 2014 and 2021 is when the first hard disk failure came up. Before that, I have used that NAS for 7 years, constant read and write, nothing happened on that device. So it's not that hardware failures are not going to happen, but when they do happen, you have to deal with it because you're the owner of that whole environment. What helps is remembering to check your smart data. So smart data is for hard disks. It tells you if the failure is occurring or not. Being cautious about noises that your hardware is making. So if your hardware suddenly starts making loud noises, the fan is running loud, or there is clicking noise coming from your hardware, you cannot ignore it directly saying, hey, some noise is happening, it'll get done or it'll get better. You can't just slap your hardware and say, yeah, this will start working properly. Any noise, any problems that you spot, irregularities that you spot could be an indicator for a hardware failure, and you just have to be cautious about it. This is exactly what ops people are going through. Someone sitting at the data center hears a noise, they get an indicator. They have smart reading coming up, and that tells them that yes, this particular hard disk is about to fail in next 2 days or 3 days, and then they work towards replacing those. Now, I don't recommend keeping spares. Generally, when you talk about corporate environments, you keep a lot of spares. So if you have a NAS running with 4 disks, you'll probably keep 2 disks as spare. It's okay to keep spares. I don't recommend, because hardware failures on say consumer grade products don't happen too often. And if it happens within the warranty time, you can get it replaced. If it is happening outside the warranty time, nowadays buying something from Amazon or Flipkart, getting it delivered is maybe a few hours work in a metro city, maybe a day or 2 in a non-metro city. So I don't recommend having spares with you all the time, but what I do recommend is having a BCPDR process, so that if your server is down or if your NAS is down, you have a way to recover your data. Now, when it comes to backup, this is a very common strategy that you have to follow. 3, 2, 1, 3 copies of data, 2 different medias, 1 off-site copy. So for example, there's a copy of data on my laptop, a copy of it goes to cloud, a copy of it remains on a local hard disk in a time machine backup. So now I have 3 copies of data at 3 different locations. There's a physical copy, there's a cloud version, so 2 different type of medias, and one of the media is not present physically with me. This is to avoid scenarios where a failure happens in one media type and you lose all your data, or a failure happens at one location. Let's say there's a fire at your location. You don't have to worry about your data at that point, because there's a copy available which you can retrieve at a later point. Now, a quick glimpse of the setup that I have built and things that you can maybe try doing at your end. So like I said, I have an ASUS router. That router goes along with me whenever I shift homes or wherever I have set up my network. That router has all of my network connectivity set up prior. So I don't care what is the IP address scheme you are using at your end. I'll just plug in your internet connectivity into my router, and a DHCP connection would happen between your internet service provider and my router. Going forward, all of my network remains as is, because I have configured it prior in my router. So that saves me a lot of time, especially because I was moving a lot. So instead of trying to reach a new destination and then figuring out, okay, log into that router, change the settings, change the numeric schemes, add DHCP settings, add static IP markings that I want, I basically decided I'll keep a separate router. So there's a second router. The internet service provider provides me a router, I connect my router to it, and then everything works from there. My own Pi-hole is there. It blocks all the advertisement traffics, all malware traffics. So there's a bunch of block lists that I've added. So a lot of my data kind of gets saved. Effectively, if I remember right, 25% of my DNS traffic gets blocked by Raspberry Pi on a regular basis, on a daily basis. And now I have a NAS, or rather 2 different NASs, which store my photographs, my videos, my audios, and my backup. And I use Tailscale to provide VPN network connectivity. So Tailscale is a proprietary software. There's an open source alternative called Headscale. It allows you to host a server of your own and effectively clients for all of your devices. So all of your devices remain on a single network till you are connected to that Tailscale or Headscale network. Then I have a personal server of mine which hosts containers and a bunch of different VMs. This is something that I bought very cheap. If you know anyone who deals with data centers, every 5 or 6 years, data centers have to discard their hardware. You can buy that hardware, it is still very much capable. The hardware that I have right now at my home costed me about 80 to 90,000. And that hardware has 40 cores in it, has 128 GB RAM on it, has 2 different processors on it, and it works wonderfully. So even though it's a 6-year-old hardware, I still have enough capability on that hardware that I can keep running it for multiple years. Plus, it's a enterprise grade hardware, a rack mount server. So I get to sort of experiment around with those capabilities also. The last point, I'll give you an example of it also. So I realized that I can host a LLM model on my own server. So I have a self-hosted LLM model, which I've then trained on my own personal knowledge management data, and it gives me interesting answers. I'll show you an answer for that also. So my cloud setup, I have a server which hosts a bunch of static sites of mine. I have the same server running a few softwares, such as Nginx server is running there. There's a Fediverse software or a Mastodon compatible ActivityPub software, which provides me my own social network. So if you go to social.anantshri.info, that's kind of like Twitter, but I own it, I host it, I have the data. So if ever the entire Fediverse is gone, my data will remain with me. Now that's my sadistic self-hosted LLM, which gives an answers like these. What's the meaning of life? It's simple. Life has no objective, point, or purpose. So yeah, fun things that you play around with when you have data or capabilities at your own home. This is a simple example or a simplified example of the data backup that I've set up for my environments. What you see here is effectively, there's a web server here which hosts static websites, and my, ActivityPub server, the backup goes to tarsnap. I have my Mac machine, that's not working. So I have my Mac machine which takes input from Google Drive and OneDrive, and the machine's backup is going into Time Machine and to a cloud entity. I have Obsidian, which is my personal knowledge management system. It backs up everything into Synology host, which is a NAS that I have locally. And that then goes to Backblaze and iDrive as 2 separate copies, because that data is critical for me. So I want 2 different copies of it. iPhone gets backed up into Synology. iPhone gets backed up into iCloud. My Pixel device gets backed up into Synology. So all these setups I can set up. And if you remember, I have Tailscale set up on my network, which means even right now I am connected to my NAS. So any photographs that I click right now automatically get synced over to my NAS. So I don't have to worry about this device sort of getting corrupted, getting destroyed. I have a backup of it already. Now, the kind of fun that you start having once you are used to doing automation. So this is my flow of how the data from different sources, from LinkedIn, from Twitter, from public websites, from say ebooks, the highlights that I extract from ebooks or personal books, to any research paper that I read, all of them get piped into my Obsidian system. And this Obsidian then gets backed up via Synology and other places. This is the actual diagram. It's not clear intentionally, but this is how the process looks. And when you get started with these automation processes, it feels fun. It gives you that dopamine hit constantly, and you keep working on it. You enjoy the whole process. Now, what I have achieved with it and what I want all of you to take as key takeaways, there's a holistic growth that happens when you start playing around with your own home labs. You understand networking. So just to set up my own environment, I had to understand networking. I had to understand classless IPs to different classes, to different subnetting schemes. I have to manage my own servers. I have to set up my own backup and recovery process. So I went through the whole idea about what is 3-to-1. Why do I even need 3-to-1? Understand the logic, deployed the logic. Network monitoring. Pi-hole is basically monitoring my entire DNS traffic. I can set up other network monitoring agents which can monitor the entire network for malicious traffic. Anything that we talk about in the corporate world, we have a very simple version of it that we can deploy in our local environment to play around with it. Even before, so let's say your company says we are going to deploy a DLP solution. Find an open source DLP solution, deploy it locally. Even before the bigwigs start talking about it, you have some idea what is the deal that you are getting your hands on. software deployment, maintenance, automation capabilities. The one capability that I'm very proud of and the one capability that I suggest everyone to have is the automation capability. If you are capable of automating stuff, you are in the position where you have moved away from being an individual who can do certain number of things to someone who is able to do more than one or two people's job. And that's a good place to be. That's about it for my talk. That's how you can connect with me. That's my name, that's my website, and that's my email address. So in the meantime, if anyone has any questions, I can take up questions. Yeah. Power consumption is going to be a problem if you constantly keep running the server at the maximum capability. Like the server that I have, the rack mount server, the actual power rating is 750 watts. I have never reached 750 watts on it. It generally dwells around 100 watts, maybe a bit less. But if you go for smaller devices, like let's say the NUC boxes from Intel, or say Raspberry Pis or Orange Pis kind of devices, they are very minimal power consumers. So a few watts and it's all done. Yes, so if you are keeping a lot of these stuff in a closed quarter, that's where fire hazard comes into picture. So you have to ensure that there is airflow around it. Again, it comes down to the logics of why data centers are AC'd, why data centers have racks and all those things. You end up realizing that, let's say rack mount server, one rack mount server sitting on your desk is fine. All you have to ensure is there is airflow available to it. The fans are there, it takes care of it. Unless you're running it all the time at 100% capability, that's when you start needing to have cooling around it. So then you need an external sort of a, fan around it. Sorry, the fan around it to take the air out. Otherwise, all you have to do is just raise it a bit from the ground, so it's not sitting on the ground, the airflow is not blocked, and that's about it.